Hello, let's look at this exponential equation. We have to ask to solve for x. X is an integer. In this equation, 4 to the power x squared minus x minus 1 is equal to 2 to the power 1 minus x. Let's quickly look at the solution. 4 to the power x squared minus x minus 1 is equal to 2 to the power 1 minus x. The base here is 4, the base here is 2. We can change this base to base 2. We know that 4 is the same as 2 to the power 2. But that 4 was raised to the power x squared minus x minus 1. So we now have this index expression equal to this index expression. That is possible. Equality is possible only when the bases are equal and the powers are equal. Now we have the bases to be equal, so we have the right to equate the powers. We have the right to equate the powers. So let's open this parenthesis. Let's distribute 2 into this expression. We have 2x squared minus 2x minus 2 is equal to 1 minus x. Let's take everything from the right hand side to the left hand side. So we have 2x squared minus 2x. Bringing this negative x this way become positive x minus 2. This positive one coming this way minus 1. So we have 2x squared. Negative 2x plus x is negative x. Negative 2 minus 1 is negative 3. We end up with this quadratic equation to solve. Alright, so we have our a is 2, our b is negative 1, our c is negative 3. What is AC? AC is 2 times negative 3, which is negative 6. Now, what are the factors of negative 6? Plus minus 1, plus minus 2, plus minus 3, plus minus 6. Those are the factors of negative 6. So we get two factors from this set such that their product is negative 1. The product is b, and so that their sum is negative 1 and their product is negative 6. So which two elements on this set satisfy that condition? That their product is negative 6 and their sum is negative 1. It can only be negative 3 and positive 2. So we are going to replace this negative 1 here with positive 2 and negative 3. So we rewrite this expression. So we have 2x squared in the place of negative 1. We are going to write positive 2 minus 3 multiplied to x minus 3 is equal to 0. Let's distribute x into 2 minus 3. So we have 2x squared plus 2x minus 3x minus 3 is equal to 0. Now we factorize the first two and factorize the second two expressions. So we have here 2x is common. We'll remove out 2x, we have 2x, we have x plus 1. Here negative 3 is common. We'll remove our negative 3, we have x plus 1. You can always check to be sure that your factorization is correct. If you distribute negative 3 into x plus 1, you're going to get negative 3x, negative 3. If you distribute 2x into x plus 1, you're going to get 2x squared plus 2x. Alright, so this factorization is correct. Again, we have to continue because we have x plus 1 and x plus 1 common. So we factorize out x plus 1 into 2x minus 3 is equal to 0. Alright, so we've gotten to this level where we have the product of two expressions giving us 0. It therefore means either this one is 0 or this one is 0. So either x plus 1 is 0. If that is true, it means x is negative 1. Or 2x minus 3 is 0. If that is true, it therefore means that x is equal to 3 all over 2. These are the two values of x. But we should remember one thing. The question says we should solve for that x which is an integer. What are integers again? Integers are positive or negative whole numbers. No fractions, no decimals. Okay, so this last aspect of our solution is very, very important. So since x is an integer, it therefore means that the only value of x that is acceptable here is x equals negative 1. This one is not an integer. 3 all over 2 is not an integer. Okay?